Welcome to TridentStack Control System Patching Guides. Before we begin, I quickly wanted to speak about the native changes that are made to Windows Update when you install TridentStack Control. TridentStack Control by default disables Windows Update and does not allow users to patch either manually using the Check for Updates button, and it also disallows automatic Windows Update patches and installations. All of updates are managed through Control by default. If you decide you do not want this behavior and you'd like to select the hybrid toggle, please review the documentation for certain implications as well as a full list of all the settings that we modify, all the registry keys that we modify. All of this is very well documented here in our TridentStack documentation under Agent Reference, Windows Update Management. Moving along, we're going to create our very first system update policy. This is going to be a manual deployment policy. Starting in system updates, notice these three system update policies that are here by default. We're actually going to be creating a clone of this one right here. So if you are trying to follow this guide along in your tenant, instead of creating this policy, if you'd like, you'll notice that the default configuration already has this assigned for you. Perfect. In order to create a policy, you can select New Policy in the top right-hand corner. And because we're creating an identical policy, I'm just going to create a policy with a very similar name here. You can select your target platforms right up here towards the top with your policy name, your description, and your policy priority. The higher a policy priority, the more powerful the policy is, and it overrides all policies that are below it, right? So if this is, for example, priority 0, and I'm fighting against a policy with priority 10, the policy priority 10 updates apply. This update does nothing. Perfect. We don't need a deployment ring on this one because it is a manual update deployment. So we want this none selection right here because that means that deployment must be triggered manually or via API. If you select the deployment ring right here, it will automatically install updates during that maintenance window. Excellent. These settings here allow you to enable installation of other Microsoft Update policies and settings, such as enabling preview updates as effectively quality assurance. Personally, I don't like to be Microsoft's guinea pig, so I do not check this button. Driver updates. Your mileage may vary with this button here. Unfortunately, drivers ship with varying levels of software quality, and they have varying levels of vulnerabilities. Some tools tend to ship a lot of drivers, and some builds and workstations need a lot of drivers. Most of the time, if you're going to a server environment, you're deploying to servers, I recommend leaving this button unchecked. Excellent. Feature upgrades allow you to do major version jumps. We typically don't recommend this as part of an ongoing policy. If you want to do a major version upgrade, we recommend you create a deployment specifically for that major version upgrade. Patch pre-installation checks allow you to put in a value in megabytes of how much disk space should be required before an update is allowed to install. We recommend you set this to a fairly high value as workstations and servers struggle to install patches when they are low on space. It both takes longer, and also if it's pulling down a compressed update file and decompressing that update file hits a disk space limitation, your update will fail to install. So we always recommend you set this to at least something. I'm going to set it to 100 megabytes. Excellent. Automatic approval allows you to specify updates to be automatically approved into this deployment. Alternatively, if you'd like to manually specify what updates you'd like to push, you can do so hitting this blue button here. But in our case, we just want to do automatic updates with the following criteria. First, we want our updates to be older than 7 days. I'm the type of admin that doesn't like to be Microsoft's guinea pig for their initial release either, because frankly, they do a bad job doing QA on patches. So I like to do over 7 days. I also like to select known Microsoft issues is false. This will say if there's a known Microsoft issue that's associated with the KB, it's in the catalog, then this will no longer push that patch. I also like to add a second criteria group for update days since release is greater than 30 and not include this known Microsoft issues callout. The reason why I do this is if a known Microsoft issue exists on a KB and it is older than 30 days, it is almost certain to say that the known issue is very low in impact. If they have known Microsoft issues that are high impact, they either pull the patch from the catalog or they roll the fix forward. If something's older than 30 days, typically it's very much an edge case where a specific area of Windows is broken in a very specific way, and it's not very impactful to servers. Of course, you always have the ability to do filtering out of various patches inside of overrides here. You can say if you know a KB is coming that is problematic, you can remove it from the patch list, even if it fits approval criteria. Excellent. Last but not least, we're going to grab this policy and we're going to assign it to our respective groups and hit Save Changes. Whoops, it looks like I accidentally assigned duplicate tags for this one because we already have that policy and this one's one that we've already created, but you won't see that error if you were to be following along inside of your own tenant here. Awesome. Going back to system update policies here, you can see this duplicate one that we just barely created, as well as these default policies here. Now that we have these policies created and scoped to our endpoints, it's going to allow us to see and have visibility into endpoints on the endpoints table that are in a pending patch status. We'll be able to see the system updates that could be applied manually. Now that we've finished completing our system update policy defaults, we are going to go apply some of the patches that are in these policies to an endpoint. To do that, we're going to go to Agents and then Endpoints to review our endpoint table. I'm going to sort by system update and select our host right here, Piper-hostname, which we will take a look at the patches. Notice the system update policy right here that we currently have assigned to this box. This is the policy that we've just configured. Here in the center of the screen under Pending System Updates, you can see system updates that are being pushed by the current system update policy. In here, you can select this three-dot menu to individually install any given update, or alternatively, if you'd like to push all the updates at the same time, you can do that under Actions and then Install System Updates. A nice feature to have is we have the ability to multi-select updates on this page as well and push system updates through this table alternatively. Excellent. Now we've created a manual package deployment and we have the ability to push updates manually, but most servers we want to deploy probably on a weekly cadence, probably right after Patch Tuesday. I like to give myself an extra day to make sure I have time to review public sentiment around how package quality is and other things like that one. So I like to do my deployment rings on Wednesday night. Let's go ahead and set up that policy now. To do so, I'll go to Update Management and then Deployment Rings. I'll create a new ring policy, and we're just going to call this one Wednesday Nights. Here in our policy builder, we can add an optional description, and then here we set up our deployment window times. We're going to have our deployment window occur Wednesday, starting at 8 o'clock p.m., and going for a duration of 4 hours. Perfect. Now I'm going to scroll down to rollout phases. Rollout phases are something that is very important to understand because it changes how updates get applied in your environment. When you select a rollout phase, for example, the aggressive rollout phase, it will initially be in a percentage-based targeting mode. That will roll out to 10% of all of the endpoints that are receiving this deployment before it rolls out to anything else. In this rollout, if it detects a success rate lower than 90% or more than 5 failures, it will stop this patch from being applied to the remaining 90% of the endpoints. We do this in order to create staged rollouts to ensure that our patches are not creating endpoint stability issues. We want to avoid a lot of circumstances that Microsoft has put administrators in the past when they push an update that maybe causes vast issues on a large number of servers or requires a large number of servers to roll back, stops them from booting, creates issues with BitLocker, or a number of other issues that do apply sometimes when patches are pushed. That's what these pilot groups are really meant to figure out. The way that I like to deploy these is make a 10% wait time for about 90% success rate and 5 failures, which is close to our default settings, and we use those with a wait time larger than the maintenance window. What that's going to do is say, let's say we hit our Wednesday deployment for 4 hours, it means only these 10% of assets in the pilot group can roll out. If this wait time was 3 hours instead, it would allow both deployments to happen in the same night because it would have an extra hour at the end of the maintenance window to run the remaining 100%. We want to be very, very careful to ensure that rollout phases are usually going to be a longer wait time than the deployment window, unless for some reason you would like multiple rollout phases to occur within the same deployment window. An example of a kind of advanced configuration where we might see this used is using the conservative preset. Let's say that we wanted to do multiple stages of rollout and we wanted our kind of test group on phase 1 to take 2 stages. It might look something like this. Configure your canary for a wait time of maybe 1 hour, right? And 2 failures with a low success rate, like probably 70%, considering how few assets are going to be in this group right here. What this will do is it will only take the first hour of the deployment and only deploy to a fairly minimal number of hosts before it proceeds to policy number 2. Policy number 2 is going to get us up to 15% of target agents deployed. So we're going to do a wait time of 4 hours, which is the duration of the maintenance window, and we'll hit save. And then we're going into our last rollout, and this one would be perhaps the broader rollout to the entire organization. So here we have, within a phase, 2 advancements windows within the 1 maintenance window, then wait and do the last one. The benefit of this sort of approach is generally it creates the ability for you to have still using the pilot group and that sort of rationale, but it allows you to have an even smaller pilot group before you roll it out to the more broad pilot group. Excellent. Moving along from here, we'll talk about a couple of the settings. Enable pre-staging of downloads is exactly what it sounds like. It downloads the update in advance, stages the KVs on the workstation in the cache of the application, and when it's ready to run for the maintenance window, it will kick it off from there. Safety controls allows halts on deployment windows in the event that they detect a certain number of failures, as well as the ability for you to manually override to proceed with the deployment if desired. Execution limits tell you how many times a ring can deploy to an endpoint within a deployment window. Each deployment window counts as one execution, including installing application updates, system updates, and required restarts. We're going to enable automatic restart after updates in this particular case, and we will not allow users to postpone, primarily because this is going to be a server-facing policy. Excellent. Last but not least, we will select these 2 options on the bottom to handle Linux rebooting as well. This allows Linux boxes to reboot services individually, as flagged by the need restart command, or alternatively, restart the operating system when required. Excellent. We're going to go ahead and create this policy now. Now that we've created our Wednesday night policy, we're going to create a new system update policy to assign to it. And we're just going to call this policy Patching on Wednesday. Here we're going to go ahead and reselect our target platform. Notice that the priority value is a higher value than the policy we previously created. That default policy of manual patching only had a policy value of 0. As long as this policy has a higher priority value, it will apply instead of that policy. In this case, we're just going to leave it as the default of 50. I'm going to modify the deployment ring to select our new one, Wednesday night, starting at Wednesday. And just like last time, we'll leave most of these settings unchecked. We'll set up a similar minimum disk space requirement and enable automatic criteria of the same settings we did on the last one. Last but not least, we would add this to our tag. In this case, we're not going to add it to 1 quite yet because we haven't made it. Now I'll go create my tag. We're just going to call it Wednesday patching. And I will assign my patching on Windows system update policy. That is all there is to it. Now we're just going to go ahead and add a agent to this policy so we can see what it looks like. Just selecting from our agents at random here, I'm going to go ahead and select these three as the ones to move. And save. Now that we're in an endpoint, we can see here that our configured system update policy is set to patching on Wednesday and no longer that default app deployment policy we created in our last video. We can also see here under the pending system update section when the next pending update is going to install. This is a selectable item so you can see what phase of the deployment it's in if you desire. That's pretty much all there is to it, to creating a deployment ring schedule and deploying applications updates, system updates according to that schedule. Welcome back to the ongoing demo of TridentStack Control. This particular demonstration is regarding rollout status definitions and answers the following questions. Number 1, how can I tell the status of my rollouts? Number 2, if I installed an update, how can I go and verify that it installed properly? And number 3, if updates did arise, where will I be able to see them in the platform? Let's start host by host. If I take a look at this agent right here, I am currently installing updates on this agent based off of our rollout demo, which is set up to go right now. Because this agent is still in progress, I'm not going to be able to see too much about it here. But whenever it's done, I will be able to see an event called System Updates right here in Activity History, and we'll take a look at that more in just a minute. Since this one's still in progress, we're going to switch host to one that is already done with the rollout. To do so, I'll click Rollout Status. I will select the rollout that I'm interested in and hit Open Rollout. In here, I can see 3 different host names that have received this rollout today. I can click the drop down to get a good idea from the last execution to figure out what exactly was installed on this workstation during this rollout. You can get a list of all the affected packages. This one has, of course, just that system updates. This is the Mac that we were just on. This is a Linux host with several third-party package updates. And it looks like this is another Linux host with third-party package updates. So that's where you can go and get a good idea about not only what executions occurred, but you can hit that View History button I just selected, and that brings you to this page, the endpoint page. You can go to History, and then System Update Install Event. You can see all the different installs that were done. This table comes in handy, and you can always filter by System Update Install to see other System Update Install events to figure out what are packages that you've maybe previously patched in your environment, or what's the rollout of other ones. You also have Application Update Install. Of course, with this being a Linux endpoint, they are managed through the System Update channel. Excellent. Going back to the rollout status page, I wanted to call out a couple of other useful features. Number 1, let's say for some reason you want to emergency pause a rollout. You can select this button right here to do so, and it will stop all ongoing deployments. Another thing I'll mention is this calendar tab. This calendar tab is amazing. It allows you to see the next maintenance window of a whole bunch of different hosts in a calendar. We have an upcoming feature to be able to export this as calendar events that you can import directly into your Outlook in order to show a Outlook event or a Google Calendar event for each one of these that you can invite your team to. Excellent. Last but not least, you can talk about one-time deployments. This would be if you were to, for example, select a couple of packages and do an action of deploy application. If you were to push an application like this one, this is considered a one-time deployment, and those can be found under that one-time deployment tab. Excellent. That's pretty much all there is to rollout statuses and patch validation. One other thing I like to sometimes mention is if there is a failure status, when it displays in this table, it will show you, just hitting my back arrow here. If you have a failure status displayed in this table, you will be able to see the exact error message that the patch hit during the install. And if you hit View in History, you'll be able to drill down and get a lot more data about why a specific patch failed to install. Another type of system update policy that people tend to want to assign is kind of an ongoing policy that involves notifying workstations. Let me show you what our default policy looks like. I'll go to deployment rings and then this one right here, workstation deployment ring. And we always include this default description tag where it exists. In this particular case, we want to install all of our patches on our workstations. I have it starting at 9 o'clock p.m. and running for 12 hours. There's a bit of logic behind the reason we set it up this way. Starting at 9 o'clock and allowing a 12-hour deployment will, in most cases, if devices are online and sleeping or unattended, have all of the updates fully installed, rebooted, and ready to go the next morning for the user. However, in the event that the user is out of the office or their host is offline or for some reason it cannot be accessed during the 9 p.m. to, morning time maintenance window time, the good news about the way this policy is set up is when the user logs on the next morning, they're still going to be in scope of this deployment window for the first hour or so. So we can prompt the user, hey, we need you to install these updates and reboot before they start their workday. Our rationale for this is update requests and requests to reboot to install updates are not very impactful to users in the very beginning of the workday or the very end of the workday. They are very impactful to users in the middle of the workday, which is why our deployment window is set up like this. It kind of gives us the best of both worlds when it comes to both unattended deployments the users don't have to worry about, but also allowing us to catch those cases of hosts being offline while still not prompting the user to reboot at inconvenient times. Awesome. In our particular policy here, as you can see, we select all the days and allow this 12-hour window. We don't exclude any dates in particular. And we run a rollout phase that is conservative, where it is a 10% of endpoints, then wait until the maintenance window is over, so effectively until the next day, before you roll out to the remaining 100%. Just like the other policies, we create very similar settings for pre-staging, automatic safety halt, execution limits, and what really changes for this type of policy that is user-facing is your automatic restart configuration. We'll leave this one as default of if user is not logged in, do restart immediately without showing a prompt, which makes perfect sense. If a user is logged in, we're going to allow it to show a notification this time, and we'll allow the user to postpone. If the user doesn't respond within timeout, we'll set this to be 20 minutes. And if the user postponings, we'll say reprompt every 30 minutes and force a restart after 8 hours. And last but not least, if it needs to reboot multiple times, this is asking how many times is it allowed to reboot in this policy. Because this is the policy that affects an end user, I like to actually set this one to 1. Other than that, all the other settings are set to their expected default values, and that's all there is to it. Let's go ahead and save this policy. This is our continued demo and recording for application update policy configuration. Let's go ahead and create a new policy and take a look. The first policy that we're going to create falls into one of the 3 categories of application patching that we've found customers doing in the real world. The first kind is called pinned application versioning. It is a great thing to implement in cases where perhaps you have dependencies that rely on things like Java or other third-party apps where updating the third-party application is likely to break your deployment for some reason or another. Typically, when people do these pinned installs, what they do is they will create, and we'll do this now, we'll create our pinned policy right here. They'll probably have it as a manual deployment only, and then they'll set up their tag assignment to their associated pinned policy tag. In this case, we're going to use our kind of example package of Java again, and we're just going to say it's this JavaScript package delegator, right? Obviously, this is not the same thing as regular Java, but we're just trying to go nice and quick here. So if we were pushing this version, we might want to pin it to a specific version, and let's say the version that we know doesn't break our software is version 4.0, right? Then we can hit add application, and anything that has a older or an earlier version of Java will update to version 4.0. Anything with a newer version, like let's say that there's a host that has version 5.0, it will not roll back to an older version. It will only update older versions to at least this pinned version. Awesome. So this is the type of policy that you might want to deploy as a one-off, and when you're ready to increment up to version 5.0, you come into this policy, you manage your edit packages, and maybe you just adjust this version up to 5.0, hit update application, and then push the deployment manually pretty much the exact same way that we've previously shown. So let's talk about the second type of application update, and this is what I like to call the prod deployment. We'll say prod, maybe we'll call it, we'll just call it keep it latest. Keep it latest is the type of application updates that users tend to do for just maintaining some of the common packages that maybe they're dependencies that still exist on the server, but you can keep them up to the latest version or keep them close to the latest version, but you don't want to patch them immediately all the time because you don't want to patch them maybe during production hours because it could cause an issue, or you want to wait till certain time frames. So for here, you could pick a given package, and we're just going to search Java again and try and find another alternative Java solution in here. We'll just pick, why not? We'll just go ahead and take this Java 8 from Oracle. So let's say you want to update Java and you want to update it every single week on the Wednesday maintenance window at the same time as the system deployments. And in here, you'd kind of add all of your standard production, keep it up to the latest version types of things. Maybe you're keeping it to the latest version. And that's pretty much all there is to it. So we'll add it to our deployment ring. And then, of course, we'll set our time as Wednesday patching so it matches our other deployment. Perfect. The other slight type of application update that I see, I like to call stale application updates. Stale application updates, I like to set to always allow so it can deploy updates at any time. And in stale application updates, I like to pick objects that get left behind on servers and generate a ton of CVEs and vulnerabilities, but they're never actually used on the server. Like, for example, Google Chrome and other web browsers tend to fall into this category a lot. A developer or an administrator or whoever will go and use Google Chrome a single time on the server when they go and grab their install from the internet or whatever they're trying to do, and then Google Chrome just sits there on that server and gets further and further and further and further out of date without really anyone ever checking on it or seeing it at all. I like to run application updates on all similar situations like this with a setting here where it will deploy at any time, and that will pretty much just keep all of these stale applications that just sit on servers and accumulate vulnerabilities. It will just make sure they're always eradicated from the tenant. Some of the other common offenders that we see of this sort of thing is Notepad++. I will add that one in there. You might add in a couple of other browsers like Firefox. Notice right here, this is a little bit unrelated, but good to talk about here. Notice that there are multiple language packs that are associated with Firefox here. This is because they have published multiple winget packages for each language pack. However, in most cases, for most applications, they tend to either have a global one or a roll-up one, or a similar type of selection where you can pick to just get all of them. But in our particular case, we're just going to find ENUS because that's what we're located out of. Awesome. We'll go ahead and do version offset -2. Personally, I like to run version offset -2 for applications like this one that are in this always update stale applications policy, just to avoid those issues where GPG signing key gets compromised or a developer account gets compromised and it allows someone to push a package with malware in it. This little version offset allows me to kind of insulate myself from that type of attack vector, to some extent, of course, within 2 deployments. Last but not least, you can add this to a tag. Now, because this is a 24/7 deployment, but it's only targeting these, it's not going to allow a full restart during the maintenance window. It's just going to let these applications reboot as needed. So we're just going to go ahead and add tag, and I'm going to put it on Windows servers and also Windows workstations. And hit save changes. And that's pretty much all there is to it. This is now an ongoing stale application deployment. If I were to go find in my environment even more, Windows administrator tools that got stuck behind and left on older versions, I would come in here and add them. Another very common one we see all the time, WinSCP. Another common one that we see all the time is PuTTY. And you can really see how this type of configuration and policy is very, very powerful at scale, because in large organizations where you have thousands of vulnerabilities in a lot of cases, it's difficult to understand how many of those vulnerabilities are actually, this is a major risk to our environment versus, 80% of these are CVE 8 and above, but they only are angry at browsers that are never opened on a whole bunch of production servers. That sort of dynamic exists across so many organizations, and that is ultimately what this type of stale application patching policy is built to prevent and to be designed for. Awesome. Well, that's everything I have for application updates. We like to set up a couple of different application update policies according to the 3 categories that we talked about, and just run 3 application update policies as a whole. So you have your pinned version manual deployments. Those tend to be one-offs in a lot of cases. You have your keep it latest version, but only patch during specific production windows for third-party applications that are used by your production tools. And then last but not least, you have the 24/7 application deployment window for stale applications. Multiple application update policies can stack on top of each other. That means that you can run this stale application update alongside this push Chrome update, alongside this managed application Windows update policy, all at the exact same time, and maybe the pinned application policy too. However, we want to address a couple of scenarios that could occur in your environment in the event that you push a conflicting policy item. So let's give a couple of scenarios. Let's say that this is pushing version Chrome 1.0 on the pinned application policy, and our pushing Chrome policy was pushing the latest version of Chrome. In this case, the pinned version of Chrome always wins. We intentionally had it set up this way in order to be a more defensive patching structure to ensure that you do not accidentally assign multiple application policies for the same package. In that case, the more protected policy wins. A similar thing is true for a hypothetical scenario where this is pushing Chrome version 2, which is version n-1 from current, and this is pushing version 3, right? In that scenario, we also pick the more conservative patch. So we will update up to version 2.0, and we will not update to version 3.0, assuming there's overlap between these policies, of course. Welcome back to another demo for TridentStack Control. This demonstration is for the package catalog, specifically the new package upload feature. In order to review your package catalog, you can select Package Catalog on the left pane. This will show all of the available package IDs that are currently managed by TridentStack Control. To upload a custom package, you can select New Package in the top right-hand corner and select the platform and name for your deployment. In this case, we're going to deploy our EDR tool, Cortex. I'll go ahead and create package. I'll select an icon, which will be Palo Alto's icon, and we'll add a version of our application and select upload for the installer. Then you put in the version of the current application. So in our particular case here, we are looking at a version 9.2.0.120. Here you can do install arguments. So this is just MSI exec under the hood. That's how this installer works. So this uses the same exact arguments that MSI exec generally does. If you have any questions about that syntax, feel free to just look up MSI exec syntax and you'll learn all about this. /quiet /qn, a quiet no restart, is one of the most common application install arguments that we see. Excellent. Once you have all of the information in your package, you can select add version and wait for the upload. Once you upload the package, it will exist within TridentStack Control in a gated tenant that only you have visibility into. We do not have the ability to view, modify, or delete your MSI packages other than deleting your entire tenant. Perfect. Whenever a package is uploaded, it is automatically scanned to figure out information such as who is the signature, what is the hash, what's the product code, and some other general information about who is the package publisher. This allows us to correlate certain security data around vulnerabilities and some other information to tie vulnerabilities to the right spot if this application did, for some reason, have a CVE get released for it. Excellent. Now that I have my package uploaded to the package catalog, I'm going to go back to custom packages and I can see it in the list here. Here's our new Cortex entry. If I wanted to deploy this update, I could do it in one of a few ways. Similar to any other application update, I could select the endpoints pane. I could select the endpoints pane. I could hit this checkbox to select any given number of endpoints, go to Actions, Deploy Application, and I can search for my application by name. In this case, because one of them was a Mac OS device, it's going to create a little bit of problems for me. Let me go ahead and select Windows devices only, like these two. I'll go to Actions, Deploy Application, and if I search, I should be able to find my Cortex device under Custom. Here it is. Perfect. From there, I could just hit Deploy, and that's all there is to it. In this particular case, however, we're going to talk about one other way to deploy it. And that is using an application update ring similar to any other one. Let's say that we wanted to add this to Managed Applications Windows. I would simply select Add Application. I would select Custom. I would run my search for my new package, and I would select it and hit Add Application. That's all there is to it. If you're looking to install this instead of just update it, you can hit this Required Application button. That says if this application is not installed, we will install it. That's another way that people sometimes push out package uploads. Excellent. That's all I have planned for this demo. If you have any questions, feel free to reach out. And as always, for rollout statuses, you can find information about one-time deployments as well as those application deployments here in the rollout status category under one-time deployments. Awesome.